Welcome to another installment of Autodesk Virtual Academy presented by none other than KETIV Technologies. We got another exciting session in store for you guys here today. We're going to be talking about PowerMill, right? What's new in 2022 in particular. And we got a real special guest here for y'all today. Alex Alvarez, AA battery, as some people call him around the office. Alex, do you want to go ahead and introduce yourself, man? How's it going?
Sure thing. Yeah, sure thing, Adam. So Alex Alvarez here, application engineer at KETIV. I've been with the company for around five years now. And again, my main focus is mostly on the manufacturing tool sets that Autodesk has to offer. So for those of you that aren't familiar with the manufacturing tool sets, it can be anything from PowerMill all the way to Fusion 360 and everything in between, right? So Feature Cam, Part Maker, Inventor Cam as well. So yeah, that's pretty much my main focus here at the company.
Yeah, Alex is a big cam guy for sure. He's probably one of our main tentpole authorities on the subject within the company. So you're going to be in good hands with him today. If you're familiar with the Autodesk platform, it is quite expansive and covers a lot of things. And so we wanted to make sure we touched on some of the what's news, not just in the Inventor and AutoCAD side, but the cam and advanced make stuff as well. So I got a lot of interesting stuff for y'all today. I think without further ado, yeah, I'll hand it back to you, Alex. Take us away, man. What's going on in PowerMill 2022 this year, man?
Perfect. Yeah, no, thank you for that, Adam. So there's actually quite a lot going on with PowerMill 22. So let's go ahead and jump into the agenda for today. Again, for those of you that aren't aware, it actually has been out for probably about a month now. So it was released May 12th, 2021. Again, if you guys aren't familiar with how to get the software or need maybe some help to install the software, we can help you guys. Just reach out. Again, you guys aren't going to get charged, right? So you're not going to get a bill at your front of the door. So let us know if you need help with installation or activation of the product. And then we are going to go into some details about obviously what's new, right? So what features got enhanced? Are there any new features that got added into the actual software itself? If you guys recall, or if you guys were here last year when I did the same presentation, we had some of the similar themes, right? So the themes were speed, quality, and reliability of the software. So we're actually going to continue that theme onto this year as well. So again, hopefully you guys have a few takeaways. It shouldn't be too bad of a webinar, 35 minutes or so. We'll go into a live demonstration at the end as well. But yeah, should be a pretty good set of features here and enhancements that I'm excited to share with you guys. So here is pretty much just a high level overview of the different highlights, right? So some of the impactful improvements that came onto PowerMill 2022. So one of them is the ability to exclude flats or flat faces when calculating certain types of finishing toolpaths. Now, again, we are going to go into a deep dive here for each one of these. Just want to cover each one at a high level overview. The other one is going to be a much more accurate flat machining toolpath, right? So again, if you guys weren't familiar, and this is something that I'm actually really excited about as well, because I got a few calls on some of the flat machining strategies, and I wouldn't say that there was an issue with it, but there was just a few quirks here and there that customers definitely wanted to see improvement on. The other one is going to be improved reliability and performance when you calculate the constant Z toolpaths. Now, specifically on parts that contain undercuts. If you guys have ever tried to machine a part that had undercuts, you might have realized that there was a little bit of finagling that had to be done in order to get the toolpath to work. Now this toolpath is much more reliable. It works as expected, and there's actually some new enhancements and a new feature that got added to this constant Z toolpath. PowerMill 2022 also includes a new option to activate automatic collision avoidance on your fourth axis and your rotary toolpaths. So again, if you're a big user of collision avoidance or automatic collision avoidance, and you have a fourth axis machine, you can now go ahead and combine those two features and use them hand in hand, right? So really excited for this feature as well. I know that we have a few customers that use strict fourth axis machines, and up to now, again, they had to find workarounds or get creative with the way that they were programming some of the tool paths. That's no more, right? So that gets completely accounted for with this new feature. The other one is going to be the use of projection ranges. So again, this is a very I would consider high end or very specific, very niche of a toolpath. if you guys are using surfaces, or maybe you guys are using curves to project onto your model, you now have the option to limit how much that projection is going to take place in terms of that model. So again, if you're familiar with this toolpath, you'll know that it takes a little bit of a workaround to get it to perform exactly as you expect it. And then lastly, we're going to talk about the staggered start points. Again, this is one of my favorites. For those of you that weren't aware, you actually can do this manually, but again, you now have an option to do this automatically within the software. So again, really excited about all this. We're going to go into a deep dive here and talk about each one, and then we'll go into the software and show you guys exactly how do you activate these features. Okay, so starting off with exclude flats, right? So the exclude flats option, how does it work? What does it do? One of the biggest things that when it comes to finishing toolpaths, obviously you're for the most part, you're going to be, well, depending on the type of toolpath that you're using. If you're using some sort of a steep and shallow, maybe a raster, or maybe a 3D offset style finishing toolpath, the software is going to try to apply the toolpath to wherever it can, right? Granted that you don't have a boundary containing that toolpath. So up to this point, if you take a look at the model and you wanted to apply some sort of a toolpath to that, in this case, it's a steep and shallow toolpath, you would have to create a boundary in order to contain it to only focus on the actual core part of in this case, the mold, right? And so again, it takes a little bit of a workaround, takes a little bit of extra time, extra picks and clicks to actually get that boundary to work. And then you would then apply the toolpath to the model itself. While now inside of those three different types of finishing strategies, you do have the option now to exclude flats, right? So again, exclude flats excludes all of the flat machining areas, as you can see here. So again, less boundaries that you have to click or create, and then making it for a little bit more of an efficient programming. And then obviously you can get your part out to your machine much faster. Right. So again, it's only going to be for these three toolpaths. I want to make sure that we're clear on that. And yeah, you have the exclude flats option. So again, it's going to look at your model. Anywhere that it sees flats, it's going to avoid it. And so now what you can do on the flats is now you can apply just a raster flat finish with a tool that can, you know, machine your flat areas a little bit more efficiently. Now, on the flip side of things, like I mentioned, we do have an enhancement to the flat machining strategy as well, right? So again, we're still sticking with the same theme of flat machining, if you will, or working with flats. But one of the reasons for that is that this is actually something that Autodesk wanted to, or one of the areas that Autodesk wanted to focus on just a little bit more inside of this new release. Again, just based on the feedback that they got from customers, and then based on some of the forums, right, that Autodesk has out there for PowerMill. So now the flat machining toolpath it's been around for many releases, right? I don't want to make you guys think that this is something that's new. This has been out for many releases. Now, the latest update sees a considerable improvement in the quality of the boundary. So again, if you guys don't know, there's actually a boundary that drives this toolpath, right? It has to still understand where the flats are at. It has to create kind of a boundary in the back end of the software. Up to this point, the boundary that it was creating, it was causing issues with the way that the toolpath was generating. A little hard to see, so I'll go ahead and see if I can show that a little bit better during the live demonstration. But we have two toolpaths here that are superimposed, right? The green one would be the one from 2022, white one would be from 2021, right? So the issue that was happening, and this is again something that I got a lot of calls on from customers, is that if you can zoom in, so if we zoom in really, really close, kind of hard to tell, but it actually chamfers the toolpath a little bit, right? So especially in internal corners. And what that would cause is that would either cause the user to add another finishing strategy, right? So again, get creative, apply a different strategy to that specific area. Or if if this was a really high tolerance part or really critical part, you would have to do some sort of hand finish, right? So some sort of manual work to get that excess material to obviously to be diminished. So now with 2022, the enhancement that you see here, the boundary that gets created is much more accurate, and now you get a true toolpath that's going into the corner as much as possible, right? So again, that's one of the benefits. The impact to you at the end of the day, what it's going to do is that obviously it's going to improve the surface finish of the parts, and then it's going to cause you to actually be a little bit more accurate on the the machining side of things, right? Because again, you don't need to apply any more toolpaths, and you don't need to apply any more sort of finishing strategies in order to get into those hard to reach areas. So really a big deal here for a lot of customers. I know, like I said, this is something that I got quite a bit of calls on, and some customers were able to catch that, so they were able to see some sort of chamfering on the toolpaths, and they were wondering why that was the issue. And again, it was just because of the boundary that PowerMill created on the back end. All right, so moving on to the next improvement. So this is going to involve the constant Z machine toolpath. So specifically constant Z with undercuts. Again, PowerMill has provided the ability to machine these undercuts with constant Z for a number of releases. So this isn't anything new, but really depending on the geometry that was being machined, the user. So if you were using some sort of let's say you were using a lollipop cutter, you can actually focus this constant Z with undercut strategy with a 3-axis machine, right? So you didn't need to use a 5-axis machine in order to machine some sort of geometry like this. But again, if you wanted to, or if you had the capabilities or the ability to machine with a 5-axis machine, you can apply the automatic collision avoidance, right? So again, automatic collision avoidance, what does it do? It figures out where the collision is going to take place, and then it tilts the tool away from either the part model or the fixture, right? Obviously avoiding any sort of collision. Now, in previous releases, the constant Z toolpath could fail depending on either the geometry, or if you combine both the constant Z and the undercut option, right? So it was failing. If you can take a look here, it was causing some sort of fragmentation. So it wouldn't fail if you would turn on the spiral option, right? So you do have the option to turn on spiral. And it would actually apply toolpath to the actual feature that you wanted to machine, but this is what it would cause. It would cause a lot of fragmentation, a lot of noise around specific areas, and it just wouldn't give you a clean toolpath, right? Again, this toolpath now has been enhanced in 2022, and it gives you a much more cleaner toolpath and gives you something that you actually expected the toolpath to do in the first place, right? So again, the obvious impact here to you is that you will be able to program these parts with greater confidence. And then again, knowing that you're going to be able to machine the part successfully, right? So again, less time trying to figure out a workaround or trying to create some sort of reference, either reference surface or reference geometry in order to get it to work. So it's going to give you that faster programming time when it comes out to actually programming this part. All right, and then this is another one of my favorites. So the 4-axis and the rotary toolpaths, right? Up to this point, again, you didn't have the option for automatic collision avoidance. Automatic collision avoidance, again, is a extremely useful feature that's embedded, but it's only capable for again, like I said, up to this point, for your 5-axis machines. PowerMill now has the ability to actually apply this to your 4th-axis and rotary style toolpaths, right? So again, it's doing the same exact thing. So keeping the same exact tool, you can see that it collides it, right? It collides here during this little feature. And what takes place then is that it's going to have to cause the table to shift or move in a specific way in order to automatically avoid that specific area, right? So again, it becomes a true 4th-axis simultaneous toolpath because all axes or axis C's are moving at the same time here. So really fascinating feature. Again, we're going to show this one in a live demonstration, so you guys are going to be able to see exactly what the machine motion looks like. But I'm really excited for this one again because up to this point, you can only do that to 5-axis parts. Now you have the ability to lock the toolpath and apply that to your 4th-axis and rotary toolpaths. Okay, projection ranges. And this is something that I was talking about in the beginning, how it's a very specific toolpath, right? What I mean by that is that when I talk to customers, not a lot of people have used this projection ranges. As you can see here, right? So this part is actually I think it's a medical component. So really specific toolpath. The way it works is that the user can create either some sort of reference surface, a curve out in space, or some sort of line out in space. And what you can do is you can translate that or project that geometry onto the model that you're trying to machine, right? So again, you can project a specific style of geometry. So if you want the toolpath to follow that geometry, or if you want the toolpath to follow a specific surface, you can do that and then project it onto the model that you're going to machine. Now, the issue in previous years was that projection, it was automatic, right? So there was no way for you to control the projection. So if you take a look at the model here, obviously this isn't correct, right? You have toolpath that's bleeding onto the fixture and onto the table of the machine. So obviously that's something that you would have to spend a little bit of time trying to update, and then trying to find a workaround to see how exactly can we trim this in order to only focus on the part that we're trying to machine. Now, in this specific scenario, we have a surface that's driving this toolpath, right? So whether that surface was created in PowerShape, or whether that surface was created in Fusion 360 and then brought into PowerMill, whatever the case was, there's a surface that was used here to drive this toolpath. Now, if you take a look at it, it's really, really hard to see. So we'll see it a little bit better during the live demonstration, but you can kind of see that overlay of the surface, right? So again, it just follows the shape of the part. It extends a little bit below the part, extends a little bit below the part here. And so again, previous releases, that projection, you can see why that's happening, right? Because that toolpath is projecting normal to that surface, and therefore it's causing the toolpath to bleed onto the rest of the parts here, which again, up to this point, you didn't have the ability to drive the extents or to specify some sort of distance that you only want the toolpath to stay within a specific range of that surface. Now you do, right? So now you have this projection range. You have to set it to manual, first of all, right? So by default, the projection range was always set to automatic, as seen here below. You now have the manual option, right? So you want to stay 5 millimeters below the surface and then 10 millimeters above the surface, right? And then that's going to be your projection range onto the model itself. Anything outside of those boundaries is going to go ahead and cut and then trim away. Right? So again, really, really neat feature. Like I said, this is a toolpath that not a lot of people are currently using, but hopefully, after this, we get a little bit more exposure to this toolpath, and hopefully people can really start taking advantage of it. Okay, so staggered start points. Again, this has a lot to do with surface finish as well. So if you take a look at the image here on the very top, right? So you can see that the lead-ins are always going to be vertical, right? So again, if you guys have been machining for some time now, programming for some time, you guys would know that this can cause some sort of a witness mark, right? Obviously, you can mitigate this by maybe having a bigger radius lead-in, or maybe having having an arc in a specific way. There's ways around it. The point being is that no matter what, it's always going to be a vertical lead-in, right? So all the points are going to be vertical from one another in a closed loop. So now with 2022, you have the option to automatically stagger these start points, right? So again, it's always going to have a forward motion for the machine, causing obviously it's not going to cause as much of a witness mark, right, as it would if you would have had just vertical start points. Now, like I mentioned in the very beginning, you can do this manually, right? Again, especially if you guys are a little bit more on the advanced side of things, and have explored some additional functionality within PowerMill, you can actually change the lead-ins for these points. And I'll go ahead and cover that during the live demonstration as well, if you do need to do that manually. But again, point being, for this specific release, you can now do this automatically, right, for these toolpaths. Again, what is the impact to you guys? Like I just mentioned, it's going to improve the surface finish. If this was a pretty critical part, or this is a part that it has to look its best, you wouldn't need to polish that, or there will be less need for manual polishing if it did have some sort of a witness mark here, right? So again, if we take a look at what's going on, pretty straightforward to see here. You can see that these lead-ins are all going to be vertical from one another, right? Whereas the bottom one, you can see that it kind of staggers them in a specific orientation. One question, and I'll address this before I want to say I get asked, can you adjust the distance between these two? As of right now, I don't think you can, right? So I think I was asked this not too long ago, at least when it was first released. I don't think you can adjust the distance between these points, right? When you do it manually, you can adjust how steep of an angle you're controlling it, but I think automatically it has a set distance from one another, right? So again, I'll have to double check that, but I think as of right now, you can adjust it if it's automatically. If it's manual, you can specify how steep of an angle you're going to be specifying these points. All right, so with that, let's go ahead and jump into PowerMill. One thing that you will note is that I have both PowerMill 2022 open and PowerMill 2021, right? So 2021 is going to be indicated with this blue background just to make sure that everyone doesn't get confused here. So I'm going to be doing some jumping back and forth here, so just be aware of the backgrounds there. So again, the first one that we're going to be talking about is the steep and shallow toolpath. Now, again, pretty straightforward. Most of these are honestly just commands that you can check on or off, right? So it's not something that you have to do a crazy amount of work to get to function or to get to work properly. So if you take a look at the steep and shallow toolpath, again, before you would have to you would have to create the boundaries, right? Or maybe even a shallow angle boundary for some of these flats, and that's time consuming, right? Even if it's something that you have to do something like this. So this outside boundary, pretty straightforward to do. But even some of the shallow angle boundaries would take some time, especially in a part like this. You have a lot of organic surfaces, what I would consider, and then a decent amount of flats here as well. Right? So it would take a little bit of work to create the boundaries on. And so if you take a look at the steep and shallow toolpath, this one was created in a previous release of PowerMill. And again, it's doing exactly as you would expect. Right. So again, we applied the toolpath. We don't have any sort of boundaries applying to this toolpath, and it's just adding the toolpath wherever it can really fit in. Right. Now, if we take a look at the 2022 option now, so the steep and shallow 2022 version of it, if you take a look at the limit tab, right, you now have the option to exclude flats. Right. So you now have this option to exclude flats. Again, whereas before, previous releases, you didn't have this option, right? You can include you can get pretty accurate with the flat tolerance, I guess I should say. So if maybe there's an area that's getting machined and you don't want it to machine, you can increase the tolerance here if needed, right? So you do have a value here that you can play around with as well. But again, for this, when you want to exclude the flats, just go into the limit tab, and that option is going to be found here at the very bottom. All right, so the next one is going to be the counterpart to this is going to be the flat machine, right? So the flat machining strategy. Again, I have macros here that are controlling this, which, by the way, if you're brand new to PowerMill, obviously macros are going to be, somewhat advanced if you're not too familiar with the CAM software. But if not, I definitely recommend you guys to take a look at macros, right? So they're a huge time saver. They help you guys with redundant tasks. So if you guys do have something that's really repetitive, and you've thought to yourself, oh, I wish there was a way to really automate this or make this, automatic. Chances are, if you're working in PowerMill, you can do it, right? So again, not only do you have your commands up here at the top, but you can record the macro. You can modify macros. You can create macros from scratch. You can take a look at some of the examples, right? So this is probably going to be an AVA for a different day, but I definitely recommend you guys take a look at the macros option here at the bottom. Okay, so as I was saying, the flat finishing strategy, right? So this is going to be your raster flat. If you take a look at, again, flat finishing from previous years, this one is a little bit harder to see. And again, if you weren't really paying attention to the toolpath, this is something that you probably wouldn't have really noticed. And if you take a look at it, a little hard to see, but you can kind of tell how it chamfers the toolpath in some areas. Some areas it does it more than others, right? So this one, it didn't really do it. This one, it's doing it quite a bit, right? So this one is pretty noticeable, even though you have, somewhat of a corner there. So again, a lot of people are saying, well, that's driven off of the surface itself, right? And in this case, it's not, right? So it's an actual boundary that's driving the flat tool path here. If I take a look at another internal corner, right? Again, you can kind of see the chamfering taking place. So point being is that, again, the boundary that I was creating, it wasn't as, I would say, as accurate as it possibly could have been. And if we take a look at this year's flat finishing strategy, right, and we turn on or superimpose the other one, right? Very minor differences, but these minor differences are what makes a huge difference, right? Especially if you're in high critical parts, making molds, aerospace parts, or medical components. This is going to be a pretty big deal for a lot of people, right? So you can see the difference already. Very minute for a lot of people, but this, like I said, it makes a pretty big deal for a lot of customers. So again, this isn't something that you enable. This isn't something that you check on. This automatically just got enhanced in the background, right? So again, if you guys were wondering how this is working, it's just automatically got improved. Now, this isn't just for your raster flat option. So again, any one of your other flat machining strategies, they got improved. So any sort of toolpath that drives off of flats or some sort of boundary like that, even when you create your flat boundaries, right? So even creating the flat boundaries, that also got improved as well. So it's not just this raster flat toolpath; it's all the flat toolpaths that are using some sort of boundary to machine the flats here that got improved. So again, really neat. Again, this is something that I consider small, but it's very effective, in the long run. Okay, and then the third benefit here, I think, was the constant Z with undercuts. Now this is a pretty interesting one, right? So constant Z with undercuts. Again, constant Z toolpath, really good toolpath. It gives you a nice toolpath when it's when it's working properly. So if I take a look at what you would experience with maybe a 2021 version. So this is a constant Z toolpath when with the undercut option turned on, right? And you're probably thinking to yourself, well, why did it miss the entire part here, right? So that's what it does. So it has constant Z. You can even tell that it tilts the tool a little bit. So it does have automatic collision avoidance turned on as well. And if I take a look at it, just to double check. Yeah, so it has automatic collision avoidance turned on. So this is technically a 5-axis toolpath, right? Now, being that it's a 5-axis toolpath, you would expect it, and obviously we have the undercut option turned on, but you would expect it to actually machine this portion as well, right? So figure out how to tilt the angle a little bit and then machine this part. This is the issue that I was talking about earlier, right? So again, PowerMill 2021, when you had the undercut option and you were using this constant Z toolpath, sometimes you would experience an issue like this. And again, it was just because of the geometry that you selected, or maybe there was something going on with the geometry. I'm not too sure why it was missing this option. Now, a way that customers were essentially going around this was by turning on the spiral option, right? So if we take a look at what it looks like then in 2021, this is what you get, right? So you get toolpath on the feature or the surface that was missing. But again, it's not the cleanest, right? So obviously it has a lot of noise, has a lot of fragmentation going on here at the end. A lot of lead-ins, right? A lot of lead-ins, lead-outs here that are definitely going to cause your machine to slow down a little bit. So not the most ideal toolpath scenario for this feature. Now, the upgrade or the update, the enhancement that has been done in 2022, if we take a look at it with the undercut, it's a little bit better, right? So now you actually get the entire surface machine that you wanted. But if you take a look at the simulation real quick, so I'll simulate this from start, probably bring the speed down just a little bit. You can still see that it has the lead-ins, right? So it's not a continuous toolpath at this point. It's still leading in a little bit. And again, it has to do with the automatic collision avoidance that we have turned on. Tilting the tool, so I'll pause it here just so you can see it, right? So it's still a really nice toolpath. The only issue that I would probably have with this is that it's leading in, and it's again just kind of spiraling that lead in just a little bit, right? So not a bad toolpath, still pretty good. But if I take a look at this constant Z undercut with the spiral now this gives us exactly what we would expect, right? So it gives us a nice continuous spiral toolpath. It doesn't stop, it doesn't lead into the surface. It just gives us a nice clean toolpath all the way around. So which options are the options that I turned on? So if I take a look at the settings, those two options are really just going to be within the constant Z finishing strategy, right? So you have the undercut option here, which again, you've always had that. And then you have the spiral option turned on as well. Right. So again, nothing else that you have to enable. There's nothing within the, something else within the tool axis or anything like that. Normally you're going to find most of these options within the actual toolpath settings, the limit settings, or as you'll see here in a little bit, you actually find some settings inside of the leads and links option. So again, constant Z finishing with undercuts, it's been improved, and it now allows for a better toolpath strategy for some of these more unique geometries. All right, and then probably my favorite one here is probably going to be the fourth axis collision avoidance. Like I mentioned before, collision avoidance, nothing new, right? So automatic collision avoidance has been around for quite some releases now. The only difference is that it hasn't been added to your fourth axis strategies, right? And so if we take a look at this rotary finish, which is again your traditional toolpath, what you would expect up to this release, right? If we simulate this one, bring the speed down just a little bit, right? So it's going around, traditional fourth axis toolpath, and then it would collide here with the actual part itself. Now, if you were working with if you're doing something with dynamic machining, what you can do is you can actually edit the tool, right, and then do some sort of rotation around the actual area that it's colliding in, right? So you would rotate the tool slightly. Obviously, that would cause the machine to move, being that this is just a strict fourth axis toolpath. You would have to come in here and then actually change the toolpath itself, right? So change a specific area and then call it a day. But again, with this, what you can do now is if you run automatic collision avoidance, and I can take a look at the setting where it's at, same exact location, right? So now inside of the rotary finish strategy, you have this tool axis addition, right? Reason why I have 2021 turned on is because if you take a look at that rotary finish strategy as well, you don't have that tool axis, right? So you don't have that tab that controls the automatic collision avoidance. So again, just wanted to make sure that you guys were aware, right? So if you guys are still in 2021 and are using fourth axis or have a strict fourth axis only machine, it might benefit you to upgrade to 2022 or at least update to the latest revision, right, of the software. So again, back in here, tool axis, if you go to the tool axis tab, you now have the option for automatic collision avoidance. And if we take a look at what it looks like with the machine turned on, right, so I'll go ahead and turn this simulation from start. Let me actually turn the opacity of this down just a little bit. Right, and so it moves the actual machine at the same time, right? So again, automatic collision avoidance is automatically doing this. You can set a smoothing tolerance for this, right? So if you wanted to set a specific smoothing tolerance or a smoothing distance, you can specify that in the automatic collision avoidance option as well, right? But again, really excited for this one. Like I said, we have a few customers that are just doing specific fourth axis toolpaths, and this is something that they were asking for quite some time, right? So now instead of stitching a few toolpaths together, or maybe thinking of a creative way to get this to work, they can just enable the automatic collision avoidance and then have the software take care of this automatically for them. Right? So really neat feature here that that's been added to 2022. All right, so let's jump on to the next one. Let's go on to projection ranges. Again, if it feels like I'm going pretty fast, it's because it's a straightforward option, right, to enable. So there's not much that you have to do in here to get some of these enhancements to work. All right, so if we take a look at this part, this one makes the most sense if we turn on the actual surface that's driving this. So if I take a look at the projection surface that gets created here, a little hard to see. Let me turn this off. but there it is, right? So that's the actual surface that gets created, or that was created, whether, like I said, Fusion 360 or PowerShape. But that's what the surface that was created in order to generate the projection. Now, if you take a look at the automatic range, right? So the previous year, so 2021 and before, this is what it was doing. So you can see exactly what's happening, right? So that surface extends here to the outer part, or to the lower part of the part, and so therefore it's extending out into the actual machine model, right, and the actual machine fixture. So again, and not ideal. This is something that we definitely don't want. This isn't what we were expecting. If we take a look at the manual range one, right, and if we go to the settings here, you'll see that that option is actually going to be found. If you take a look at the limit tab, actually projection range tab, there's a limit that you can now give it. Now, this image, honestly, to me, when I looked at it, it was a little confusing. If you look at it here, it kind of makes sense, right? So if you look at it here, so it's projection, you're giving it a lower limit and then a max limit, right? But if you look at a part like this, how does this kind of represent that, right? So the best way that I feel like I can think about it and kind of let you guys also see it is by the thickness of it, right? So you're specifying essentially, so if you can kind of think of an offset that gets thickened, right? So you have an offset here of +10, offset here of -5. That's more or less how you're controlling where the toolpath is going to go on, right? So obviously it's going to try to machine this part, but depending on this distance that you give it, so that offset distance is what I would consider it, is what controls how far the toolpath is going to go into the part itself, right? So again, it's going to take a little bit of testing here. But once you get the hang of what exactly the software is doing, you'll be able to see this distance, how it plays a factor inside of this toolpath, right? So again, the way I can think of it is an offset, right? So that's the way that I envision it in my head. It might be different for some of you guys, but the way I envision it is you have an offset, so you're offsetting 10 millimeters, you're offsetting -5, and then anything in between, it's going to add toolpath to that specific region. So again, surface projection toolpath, that's going to have now a projection range option, and then it's going to have both a minimum and a maximum, right? So instead of automatic, you now have the manual range there. All right, and then the last one here is going to be the staggered start points, right? So let's go ahead and run that part real quick. Okay, so if I activate the no staggered links, right? So I'll take a look at this part here. My 3D mouse is just super sensitive today. So if I take a look at it, right, exactly what that image showed in the PowerPoint, it's vertical, right? So these lead-ins are always going to be vertical. If we take a look at the staggered links option, it's going to stagger them across the entire toolpath, right? Or the individual step downs that you see here. Again, if you take a look at the settings or take a look at where this was activated, this is going to take care of inside of the lead-ins, right? So lead-in links, you now have the option to stagger the start points. Go ahead and edit this. So again, you click on leads and links, you now have the option to stagger start points, right? So that's the only option that you have to enable in order to get this to work. Now, like I mentioned earlier, and let me see if I can rotate this without spazzing out here. There we go. Okay, so I'll go ahead and turn on this no staggered links. Like I said before, you actually can edit this manually, right? So if you wanted to move the start points, you have the option under Toolpath Edit. So click on Move Start Points. You can either do a single start point or you can do multiple, right? So if you want to do multiple, let's say you wanted to start maybe on this this internal fillet, this internal corner, you draw your line, right? And then accept it. And then it's actually going to move the start points for us, right? So this is how you have a little bit more control. Like I said, I don't think right off the top of my head that there's a way to control the points automatically, right? So if you wanted to control the distance from one another, or maybe, I guess in this case, if you wanted to control based off an angle, I don't think you can do that, right? So if you want a little bit more control over that, you might have to give this this move start points a try which is obviously the more manual approach. But if not, if you're okay with just staggering, if that's all you're looking for, then the automatic stagger points in the leads and link option is going to be the way to go. And so that's the last one, right? So again, really straight to the point enhancements, but I think these small enhancements go a long way, right? In terms of both surface finish and programming efficiency. I think this is gonna be a pretty big deal for a lot of customers out there that are currently using PowerMill as of right now. So let's go back to the presentation real quick. Again, just a quick summary here of what we covered, right? So finishing toolpaths, you now have the option to exclude flats. And again, for the finishing toolpaths, the exclude flats option, you're only going to see that in the raster toolpath, the 3D offset, and the steep and shallow toolpath, right? So those are the only three finishing strategies that you're going to see the exclude flats option on. We talked about the more accurate flat machining, right? How the algorithm or the boundary that gets created for the flat machining got updated just a bit. Constant Z machining with undercuts also got an enhancement, right? You get now a much cleaner toolpath. You get a toolpath that actually does what we expect it to do in the first place. Projection ranges for curve and surface projection toolpaths. You now have a option in there to control the projection manually, right? The projection distance. And then we talked about the fourth axis and rotary collision avoidance, right? So you now have automatic collision avoidance for your fourth axis and your rotary style toolpaths. And then staggered start points to give you a greater surface finish. There's actually a couple more updates that I didn't talk about. So for instance, probably one of my most favorite ones is going to be this incremental project saving. Up to this point, if you save the project, right? So if you save the project, you opened it maybe a week, 2 weeks later, and just made a small change, it would save the entire project, right? So there was no way for you to decide, okay, I just added this difference, I'm only going to save this part. Nope. It saved the entire thing. So that can be time consuming. As of this new release, it's now going to be an incremental project save function, right? So what that means is that you're going to have a project, you're going to save it. If you make a change to it a week from today, it's only going to make a save to that change, right? It's not going to do the entire save all over again. So again, really neat functionality. And again, hopefully that saves you guys quite a bit of time, especially if you guys have some pretty gnarly projects there. Display of pattern instrumentation is sped up. The 3D offset toolpaths with centerline option. This one's actually a pretty neat one too. If you have finishing strategies, the tool is going to leave cusps, right? Especially if you have some sort of finishing strategy on an organic surface. You now have the option to turn on the centerline option, and what that's going to do is instead of machining around the cusp centerline, it's going to offset that, right? And it's going to machine that on the actual cusp itself. So again, really neat functionality. I think if you guys want to learn a little bit more of that, let me know. I can send you guys a quick video, or we can get on the phone and show you guys how that works. But again, it's just a really nice feature that got added onto the new release. And like I mentioned, if you guys want to download this, if you guys are new users or existing users, you guys can go to your desktop app if you guys have that. It should have the latest revision or the latest version of PowerMill there. If not, if you guys don't have the Autodesk desktop app, you can go to manage.autodesk.com and then download it from there. And then lastly, like I said, if you guys need help with installation or activation of your software, go ahead and reach out to us. Don't hesitate. Autodesk obviously can help you guys out too. We can help you guys out. So just reach out to us and we can go ahead and help you out with the installation here. And so this is what it looks like, right? So access my complete list and then download the software there. This is what it looks like inside of the manage.autodesk.com. If you guys ever need any help on any of the manufacturing tool sets or really any of the Autodesk tool sets, the design and manufacturing side of things, feel free to reach out. I'm always interested to learn more about, your custom workflows or your workflows. How are you guys currently using both the design and manufacturing tools? So, just feel free to reach out, have a quick chat about, your current tools.
Beautiful. Yeah. Well, yeah. Let's take a moment then. Feel free to submit any questions if you guys have any. Again, there should be a Q&A button located somewhere in that action bar for the Zoom webinar. And of course, feel free to reach out to Alex or the rest of the team here if you need anything else from there. But take a moment. Now, a lot of good stuff in 2022. Are you going to be doing similar events for maybe like Feature Cam or PowerShape or something like that, Alex?
Yeah, I think Feature Cam might be the next one.
Mm-hmm.
As well, we're getting a lot of traction with Fusion 360. So
Oh,
they're
I see.
always
I see.
they're
Yeah.
they're
Always on
they're
the
always
heels of everything else,
yeah
huh?
they're always updating that software. So I think we have a dedicated channel to Fusion 360 as well. So
That's right. Yeah.
I,
And you also host for that too. Is that correct?
that's correct. Yeah,
Man, you just love being in front of the camera,
I do.
huh?
Yeah, I do. I think I picked the wrong career here. I've been a news anchor or something.
Well, Hollywood's always going to be there for you, man. All right.
Yeah. All right. Well, I don't see any questions here, but like I said, guys, here's my contact info. Feel free to reach out should you guys have any questions. And thanks for tuning in.
Sounds good. Thank you, Alex. Thank you, everyone. And again, there's a survey going out if you guys have any feedback. So just let us know if you want to learn more about anything else from here. Have a good one, everyone. And
All right, guys.
we'll see you guys next week.